Hello, this is Jer, and I'm showing you the theory of building a power plant, or nuclear power plant, rather. So I'm starting with solar panels, not technically part of this power plant, but I'm going to build this nuclear power plant on the top left corner of my base. And I figure it'd be wasteful if I didn't put solar panels on top to take advantage of the light that's shining on this asteroid. So I'm starting off with insulated tiles made out of ceramic. Now I could make that out of insulation, but I want to design this such that I can build this thing earlier than later. So currently just using the dev tools, but I want to make it out of materials such that if I were to do this in actual game with my dupe screen and resources that I can find within the world, I don't have to wait until much later on. So here I'm making this out of granite, and the reason I want that is I want a material that's going to be a good conductive or be good thermal conductivity, meaning that it's going to transfer heat decently. So now I've got a second layer, and this is where I'm going to have additional steam turbines, because at the core of this nuclear power plant is going to be a nuclear reactor, or research reactor rather. And that thing produces radiation, which is useful for generating radbolts, but it produces a ton of heat. And it specifically outputs steam, very hot steam, and additional heat on top of that. So that's why I am an excessive amount of steam turbines to take in the steam that this thing's going to be producing, and then throw in, I hate this bug. I see they haven't fixed it yet, but anyway. What was I saying? I want to take the hot steam, turn that to essentially hot water, and then throw that back on the research reactor. Even though it's coming out at 90 to 95 degrees, it's still having a cooling effect. And everything inside here that needs to be made out of fine metal is going to be made out of steel. As I mentioned, I don't want to have this built in an advanced stage of the game. I want to build this after I'm able to generate plastic and steel and the ceramic. So those are the two main ingredients that I need. So plastic, ceramic, steel, and everything else will just be standard materials that you should have in any asteroid. So I've got to have some drywall within this location here, because otherwise if I were to release some steam out of the research reactor, it's just going to go out in space. And that's not helpful whatsoever. So I'm going to fully cover in this area. So now I'm going to put drywall underneath or behind the steam turbines, just at the bottom tile. That's because I'm going to store some water there, because I don't want those things to overheat. You don't want them to get above 100 degrees. So I'm going to store water and keep the water cold, or at least under 100 degrees, so these things will continue to operate. And I'm putting some insulation tiles on the edges. Technically, those could be just regular tiles, but figured I'll make it out of that. So here is the core to this nuclear power plant, a research reactor that is going to take enriched uranium and water as coolant, and then produce massive amount of heat, throw out some steam, as well as radiation. So this is radiation level before this thing's turned on. Now I want some Radbolt generators. So this is going to take the radiation that this thing is going to output and then convert that to Radbolts. Now a downside to those things is they take a lot of power. So what I'm going to do is I'm going to put some automation wires in there such that I can turn on and off a subset of those guys as I need. Now the other thing that I didn't mention that the research reactor outputs is nuclear waste, which isn't terribly useful. It does have a good thermal conductivity, so I actually want a little bit of it on the bottom in this area, so I can disperse the heat from the central research reactor to the edges at the bottom of this, and a little bit of nuclear waste will actually be beneficial. So that's why I'm building a pump at a bump up level here, so that that nuclear waste can make its way out. If it gets too high, the pumps will take it out, but otherwise it'll actually, a certain amount of it, hopefully not more than just one or two tiles worth, will sit there and act as a thermal conductivity. So just going to also put in 2 aqua tuners. And the reason for that is I want a system to keep the water that's sitting with the turbines to be cool, or at least under 100 degrees, as I mentioned earlier. So I've got some insulated tiles that they're sitting on, and I'm going to put that through insulated pipes made out of ceramic. So that's going to go down, and the idea there is when water or whatever liquid you're going to put as coolant goes up into that thing, it's not going to get over 100 degrees if it's water anyways, and bust your pipes. So I'm going to do the same thing with the research reactor. Research reactor must be water, whereas the coolant can be other things if it can be the appropriate temperature. But I'm going to use water. A good one would be salt water, polluted water, as it can be more negative, or it can be up to -10 or -20 depending. But I expect that the temperature will be somewhere between 20 and 40 degrees as I maintain it with those 2 aqua tuners. All right, at this point, I'm pretty much just powering everything on. I'm using the refined metal to construct this. You could use a heavy watt wire that would most likely do. I don't expect that I'm going to produce much more than 10,000 watts of power. So turning on all the Radbolt generators, again, I'm going to put an automation there such that I might not necessarily actually run them all. I just got a little tile there I didn't expect to have. So everything's got to be powered in the pumps, aqua tuners, and I'm going to have some pump or liquid shutoffs next. That's going to go into the input of the aqua tuners. That also will need to be powered, but I'll worry about that later on. So I actually have an active wire there. That's because the solar panels are already producing some power. I'm going to connect this with the rest of my base, just so I can jumpstart this whole system when it's ready. Now the neat thing is the research reactor doesn't need power. It just needs its input. And you notice I've got an auto sweeper there that is made out of steel. Everything here, as I mentioned, is made out of steel if it needs refined metal. But anyway, that also has a chute next to it that my dupes can throw in some enriched uranium for that to operate. Okay, so now I'm working on a pipe system that will cool off this water, because as these steam turbines run, they're going to take on heat. And that water that's sitting next to them, once that gets over 100 degrees, well, first of all, it may evaporate. But second of all, if the steam turbines get above 100 degrees, they stop operating. So these 2 aqua tuners, I want to be selective about when water goes through them. Because if water did get cooled down to below 15 degrees, it would actually break, because it would essentially be turning into ice. And that wouldn't be a good thing. So the idea here is I'm going to run it through this. But, as I mentioned earlier, I'm going to put a liquid shutoff next to it, so I can control whether it goes in the aqua tuner or it doesn't. So I'm putting it out over here such that it's going to converge with the output of the aqua tuner and then go inside this liquid reservoir. And the priority is going to be set that the aqua tuner, output of the aqua tuner, would be a higher priority. So I'm putting 20 degrees on this temperature setting. So if it's 20 degrees or higher, then operate the aqua tuner, put water, send water towards that so it can be cooled. Otherwise, if it gets to a point where it's below 20 degrees, skip it. And I'm going to have a second one here because one isn't enough. I've tried this before with just one aqua tuner, and it slowly heats up. It does, slows down the process. I'm able to operate the steam turbines for a lot longer without it, but without a second one, it will eventually run into overheating problems. So exact same setting, 20 degrees. So let's say, for instance, the first one is getting about 40 degrees temperature. It'll operate, and then it'll get down here. And if this gets down to 21 or 22 degrees, it can continue to operate. So every single steam turbine is going to get this radiant pipe. And wherever you're operating in or setting the pipe in space, that doesn't need to be the radiant pipe. So just save that for just the area that's connected to the steam turbines. Okay, so this is the logic that's turning on and off that liquid shutoff. All right, so the other bit that we need to worry about is loading this whole system with water. So I already have a base that's operating. I've got tons of water supply in it. So I'm going to load this whole thing up. And I'm definitely not going to turn the research reactor on, as in provide it with input, with enriched uranium, because if I don't have enough water and the rest of the system to cool it down, bad things will happen. Anyways, I have a different episode. You can look for a research reactor blowing up, but I plan to not do that in this little video. So I'm going to have 3 liquid reservoirs that's going to be filled up before I even think of turning this machine on, because the moment it's on, you do not want to be in a situation where you can't provide it with water. So I'm going to fill up those 3 things and then get a water circulating around so that I know that I can keep the steam turbines operating before even throwing the switch on. Speaking of the switch, I'm now going to actually I'm making this out of steel. And I'm going to put an ability to control which Radbolt generators are on and off. So I've got 3 different arrays, as well as a switch for the actual research reactor. I built an extra one there, I didn't need, but anyway. So that is good. They're all going to be turned off to start with, in particular the research reactor. But the Radbolt generators, it's important to turn those off too, because they produce heat and they consume a lot of power. And at this point, there's no radiation, so it would be pointless. You can, however, as I am right now, fill that with water. It's not going to do any harm to have that sitting with water. And I'm just going to cheat a little bit here. I'm just going to add some water, destroy some flooded steam turbines, and rebuild those. So I plan to build this system, if it operates correctly, and I expect it will, because I've already done similar tests on very different or very similar models as this, with a couple small changes. But anyway, I plan to have that operate or be installed in actual gameplay in the Moonlit series that I'm playing right now. And if you want to see that, you'll have to wait for the next few videos, but eventually I'm going to build this thing on my main base. But I'm going to use dev tools, and the reason for that is it's just one of those things that it takes so long to build, and there's so many variables to this research reactor that I'm not in the mood for experimenting by having dupes do something and have to reconstruct something. I've already gone through probably 5 or 6 iterations of this machine. Anyway, enough on that. So what I'm doing now is a method for distributing the heat from the edges. Because what I don't want to have happen is I don't want all the heat be with the research reactor, and at the far edges of those steam turbines that are at the end, if they're not hot enough, they're not going to operate. And so what I need to do is get the heat that's being generated here and send it to all areas of those steam turbines for cooling. So what I'm doing is I got a conveyor rail, and I'm making 4 paths. I've got 2 of them right now, working on the 3rd one, and they're going to go to each of the wings. I've got 4 wings that's going to go around. I'm going to try to avoid the insulated area, because the whole idea was to have that protected from the water pipes that are going in. But so the most of the heat, by the way, from the research reactor is going to be from the bottom of it. So that's where the far amount of heat is, and that's also where the nuclear waste will accumulate. All right, so I've got that. I'm going to put somewhere in the base this conveyor loader, and I'm going to have granite be provided as input. I'm going to allow my dupes to load that. Now, you can use better materials, one which would be aluminum. It's one of the best that you can get early on, but I think that's a waste of refined metal. I think granite will work well enough. So I'm going to fill this these 4 chutes or these 4 lines with granite, and send all 4 of them in an infinite loop that doesn't require any power to operate. So I just need to load it once, and then I'll be able to connect this in such a way that they'll all operate or in an infinite loop. So the secret to loading this thing with granite and making this infinite loop is really just a conveyor bridge. So I'm providing one end of it, and I'm specifically designing it in such a way that the direction goes on the bottom and then out from the research reactor. So it's going to go from the hot research reactor and it's going to go through the granite tiles. That's going to have the best heat exchange. And then it'll make its way on top where it'll have some extra heat exchange in the steam, and then go back to the hot research reactor and then back again. So all 4 of them are going to be cut at one spot. I'm going to temporarily have this conveyor bridge with a input on the very end, and my dupes, you can see they've already started to load the granite in. So that granite, I'm just going to wait till that fully fills everywheres, and then I'll destroy that rail line going in, and I'll connect a bridge such that we can get this thing going in an infinite loop. While I'm waiting for that to load, how about we continue on with another part of this system. So this is going to be the liquid vents. I'm going to have multiple liquid vents, and this is what's responsible for cooling the research reactor. Because as I mentioned before, I built things out of steel, and if that thing gets higher than 275 degrees, things will break down. So I'm going to have different lines, one for 5 of the steam turbines on the left, and then 5 for the one on the right. And the reason I have 5, that's maximum that you can have with a single pipeline, because each produces 2,000 grams of water, and a pipe can handle 10,000, meaning that once you've got 5, one will have to shut off and wait for a pipe to be available. So you don't want that to happen. So maximum that I've got is 5, and I've got 10 on the top, so 5 and 5 for there. There'll be 2 liquid vents and 2 pipelines going out. So that is going to be providing the cooling effect, throwing that right on top of the research reactor. Now I'm going to have a second line that goes out of this as well. And this is to actually go to the input of the research reactor, because ultimately I don't want to have to continually to supply water forever. I want this to be a fully inclusive system, apart from the little bit of enriched uranium. So now I'm having the steam turbines on the side. Have a separate line again. The other 2 lines are max, so they're 5. So this is 3 and 3, so they're going to definitely be fine. And this one is just going to be for cooling. So these 6 are, and I'm making sure this is insulated piping made out of ceramic. Those 6 are specifically just throwing water on the research reactor. And the only reason for that is it's just not necessary. It's also a smaller space to work with to get the second water line out of there. So that's the only reason that I'm doing that. But that is going to throw additional waters on the research reactor. So I've got 4 liquid vents in there to keep that thing cool. So last test that I did, where was I at 10 or 12 of those steam turbines, and that was not enough. That had a slow heating effect such that about 50 cycles or so, it was clear to me that I was going to pass 275 and have the sweeper and the pumps break. Okay, so now my system is filled with granite, which is amazing. So that I'm going to have a few conveyor bridges, and I'm going to put the direction such that it's going to go in the bottom area first and then go towards the top for all 4 of those wings. And it really doesn't matter where I put this. All that matters is there's at least one tile in the conveyor rail that's free. If everything is completely booked in terms of the conveyor rail, it won't move. So you may need to destroy a single conveyor rail to make this happen. I think that's what's going to happen there. Yeah, you notice I installed the conveyor rail and it didn't move. So I'm going to have to destroy one and then put it, same thing is going to happen over here. So pretty easy fix. Just as I mentioned, and get rid of some of those extra wilds. Just destroy a single one and then connect it, and then everything will run. And the really nice thing about that, there's no power required. And because it's granite, that's a pretty good thermal conductivity, and especially if you put it through tiles, it'll really transfer the heat that's coming from the research reactor through all four wings, so that all steam turbines can take and handle some of the heat, and not just the ones that are just above or next to it. All right, so that is the importance of the conveyor rail. Okay, I'm going to repurpose the dupe's input to this conveyor rail. That's going to be ultimately the new line that's going to provide the enriched uranium. And I may need to print this since I don't actually have access to it in this base, but that's fine. So I'm going to have that dropped off in reach of the sweeper. And the sweeper is in reach of the research reactor, so it can actually load it. So no dupe actually has to go in that area to load more enriched uranium. They can put it in here. It doesn't have to be this location. You could have it closer. Just be aware that the conveyor loader does produce heat, so you don't want it sitting in space. So I'm just going to produce a massive amount of rich uranium. I do not need that much for my testing, but I'd rather just have more. But anyway, so my dupes, I'm going to allow manual use. They will put it into that system. And I have the switch off, so even when that enriched uranium reaches it, it won't actually be loaded until I throw the switch. Okay, that was a large setup, but I'm now ready to throw the switch. And as soon as I do, that auto sweeper is going to throw in the enriched uranium. And the first thing you'll notice as it operates, it throws steam out next to it. And that's pretty hot steam, but the tiles next to it are cool. So it's initially condensing to water on the bottom. And you can even see some green nuclear waste be produced. So that's not going to last long, the water that is on the bottom there. That will get to a point where it's so hot that every bit of it is steam. Let's have a look at the radiation that this thing is generating. Quite a bit. Around 7,000 to 8,000 in the center next to those Radbolt generators. So they're going to operate very effectively, and I'll get a lot of Radbolts out of this system. So that is one extra benefit. Well, it depends on what your goal is, whether to get the Radbolts, which actually is a very useful thing in this game, or just the power, or most likely, in my case, both. So I definitely want to have the Radbolt generators next to that thing to take advantage of it when I need that. So just be aware at this point, because that steam is low pressured and it's not hot enough for the steam turbines, that's not actually producing any power. So if I did put the Radbolt generators on, I would have to make sure I had an alternate source of power in order to run them. They almost take about 500 watts each, so two of them will be 1,000. It takes a lot. Now, my base doesn't have that much power, so I'm going to wait till those steam turbines run before I consider throwing the switches on the Radbolt generators. Okay, you do not want to wait long once this thing is on to turn on the water line or whatever liquid you've got going around cooling off the steam turbines. So putting that on at this point. So it's going to go around the entire set of steam turbines, and it's going to visit the 2 aqua tuners on the way as it was configured before. So that's going to operate. Actually, so just notice a little bit of water is accumulating next to where these 2 pumps are. So I don't want them to operate until there's a point where there's no more water. It's just steam and the nuclear waste, because I designed those pumps for the nuclear waste, not water. So anyway, what was I saying? So water is making its way to visit every single steam turbine to make sure that they stay cool. And because the steam turbines are in space, it's very important that you have water or some other liquid sitting next to them so that you can transfer the heat from the steam turbine to that radiant pipe in the water that's inside of that. So that is, as I mentioned, visiting two steam turbines. You can see, or aqua tuners rather, that's going to take the temperature of those down. So that will also produce a little bit of heat inside this whole system. Now at this point in time, actually I can see a few steam turbines just operating perhaps 50% or less. So we're getting a bit of power, but because the two aqua tuners are on, I'm consuming more power at this point in time than I'm actually producing. So just be aware that you're going to need some sort of power to get this whole system kicked off and running before it's actually providing power for your base. Just a quick view of the heat. We're almost at about 150 degrees. So I'm making a little change here, getting rid of that top line that is going to provide the water. It was getting confused, and I'm going to put liquid bridges and just send the message to it that once it goes in this direction, don't send it back and in such a way that goes in a circle, as what was happening for a little bit. So pretty much exactly the same thing. Each of these steam turbines has two options for outputting water. One can go towards liquid vent at the bottom, or it can go up, providing water back inside this steam turbine. And I'm not going to operate that until I can measure the steam inside this chamber reaches about 100 kilograms. So I will let new water keep feeding that system and just keep that new pipeline that I built on idle in unconnected state until I get that pressure of 100 kilograms. Okay, so this thing has been running for about 20 or so cycles, and a lot of nuclear waste has accumulated there on the bottom, and everything looks pretty good. The steam turbines are all operating, not at 100% capacity, but a little bit more than 50%. And that's producing quite a bit of power for me. So I'm now at the point where I'm registering 100 kilograms of pressure where the steam is. And I no longer need to actually have water be provided into the system. So it's self-sustainable from a water perspective. So that's quite nice. So any of the water that's produced in my base can be used for oxygen or other things. The water that goes into the research reactor is only going to be provided from the steam turbines. So that is a great thing to have. If you are experimenting with higher pressure values than 100, avoid anything that's 200 or higher, because at that point I wasn't able to get the research reactor to vent past about 200 kilograms, and I got a meltdown. You don't want that to happen. So 100 is a safe number. 150 maybe. Any higher than that is I'm considering a bit risky. So now I'm at the point, probably past the point actually, I could have already had the Radbolt generators operating. So just moving some area over, because what I want to do is have a pass-through area such that the steam is not able to escape, but the Radbolts can. So I'm going to build, so just move some, oh crap, let me fix that. So I've got just moving the pipes and power lines over, so I've got a little bit of space here to operate. So I'm going to build sort of a bump up type station. I'm going to have this joint plate for the Radbolts. That's going to actually melt, and that's by design. And just make sure that I got the drywall in there. So initially that will have no problem start sending those Radbolts out through it and prevent the steam from getting out. But it will eventually melt in such a way that the material that it melts into will continue to block out the steam but allow the Radbolts to go through. So I have turned the switch on 2/3 of them, the Radbolt generators that is, and there's not quite enough power in this whole system to operate that many. I definitely have installed more Radbolt generators than I would likely operate. So I'm just going to have one of the rays turned on at a given time. Okay, it is 60 cycles since I last checked on this, and an excessive amount of radiation, or rather nuclear waste has accumulated, and it's actually such that it's blocked the steam going off on the bottom right wing. So I'm actually changing the system that's going to pump out the nuclear waste. It's going to put it very next to it. So nuclear waste tends to clump in this sort of fashion. It doesn't spread out nicely. So because of that, connected the wrong wire there. But because of that fact, I want to put a gauge there. And it's going to detect, I'm going to put it for 900 kilograms or higher. If that's the case, then run the pump. Otherwise, turn it off. And I actually do want a little bit of nuclear waste, just as I mentioned earlier on in this video. It actually is a good thermal conductor, and will actually help send the heat that is inside the research reactor on both the left and right directions. So I do want to have a little bit of it. Just for that purpose, but I certainly don't want to block off any of the wings, so that will hopefully alleviate that problem that I've got. One other thing I'll point out about the nuclear waste is it actually reduces the amount of radiation that the Radbolts that are sitting in the nuclear waste as opposed to the steam have access to. It's about a difference between 6,000 to 8,000 roughly. So I'm recommending, if you're only going to operate so many, choose the ones that are higher up rather than the ones down there. So the ones that are on the bottom inside the nuclear waste, I'm going to disable. All right, also just noting that my Radbolt joint plate had melted into this black material. That is not a problem because it's actually preventing the steam from getting out and Radbolts getting through, and that's entirely the system that I want. So I just need to add in the another Radbolt reflector made out of obsidian that's not going to melt. And there I am able to get the Radbolts out of this system easily. Okay, about another 10 cycles or so ahead. I'm getting temperatures in nuclear waste of 175 at the bottom. 160 everywhere else, so it's maintaining its temperature quite well, which I'm glad to see. I'm getting a lot of Radbolts out of this, even though I only have about 5 of them operating at this time. And I am getting, with the Steam Turbines, almost 9,000 kilowatts of power. That's awesome. That's going to allow me to do a lot of cool things in my base without having to worry about power. Just keep in mind, I do have 2 aqua tuners running, so you do have to subtract that. And if you are operating the Radbolt Generators, it's almost 1,000 for 2 of them. So you'll have to take that into account. But in addition to that, I get lots of Radbolts coming out of this that I'm just throwing out into space. I'm just testing it. But in actual gameplay, I'm going to build this whole system and from without the dev tools, and have my dupes do it and do some really cool things in my playthrough, which I'm putting up in my videos, so look for those. Anyways, I hope this works out in your base if you're going to install this. Otherwise, just enjoy watching and hopefully see you in another one of my videos.